The function f is defined piecewise. F of x equals sine of x if x is less than pi over 4, otherwise f of x is cosine of x. We have to show that this function is continuous everywhere. Now, sine of x and cosine of x are, as trigonometric functions, continuous in their domains of definitions. Since sine of x and cosine of x are defined for all values of x, they are also continuous everywhere. So sine of x is continuous when x is certainly less than pi over 4, and since cosine of x is continuous everywhere, it is also continuous when x is greater than pi over 4. This means that f of x is continuous, except maybe possibly not at x equals pi over 4. So we have to study continuity at pi over 4. And to do that, we observe that the value of the function at x equals pi over 4 is cosine pi over 4, which is 1 over square root of 2. To show that f is continuous also at x equals pi over 4, we have to show that f has a limit, which is 1 over square root of 2 at that point. F is now piecewise defined. Therefore, it is most convenient to consider one-sided limits. The limit of f of x as x approaches pi over 4 through numbers larger than pi over 4 is the same as the limit of cosine of x as x approaches pi over 4. This is 1 over square root of 2. The limit of f of x as x approaches pi over 4 through numbers less than pi over 4 is the limit of sine of x as x approaches pi over 4, but this limit is also 1 over square root of 2. Since these two one-sided limits are the same, the function f has a limit as x approaches pi over 4, and that limit is 1 over square root of 2. And this limit is also the value of the function at x equals pi over 4. This means that f is continuous also at that point. We conclude that f is continuous everywhere. In this problem, we consider the function g of x, which is defined by setting g of x equals square root of x plus x divided by ln of x minus 1. And our task is to figure out where this function is continuous. So first we have to figure out where it is defined. The numerator, square root of x plus x, numerator is what is upper part of this fractional expression. This is defined when x is greater than or equal to 0. Square root of x is not defined for negative numbers of x. So this is defined and continuous when x is greater than 0. The denominator, the lower part, ln of x minus 1, is also defined for all values of x greater than 0, and ln of x minus 1 is also continuous for all values of x greater than 0, but it takes a value 0 at x equals e. E is the basis of natural logarithm. The red curve is the graph of the function g, which is shown here. So this function is not defined at x equals e, and therefore it is also not continuous at that point. And in conclusion, g is continuous for every positive real number different from e. Problem 5. Where the function tangent of x is continuous. Tangent is sine of x divided by cosine of x, and by previous remarks that we have done regarding continuity of functions, tangent is continuous everywhere where it is defined. So sine of x divided by cosine of x is defined whenever cosine of x is not 0. Therefore, this function tangent of x, sine of x divided by cosine of x, is continuous for all values of x which are not pi over 2 plus a multiple of pi. This red graph shows the graph of tangent function together with the vertical asymptotes that corresponds to the values of x equals pi over 2 plus a multiple of pi. So tangent is continuous everywhere except not at points where cosine of x is 0.